Bet she's got a location on shore. You ready for this?
Let's find out.
Hello everyone, it's me Arvind catching you on another Math Tutor Edu's lecture video. Okay, in this lecture video we have come to the end of the last subtopic of the application of differentiation, which we are going to cover the small changes and approximations. Okay, so before going through the formulas, I just want to show you what is exactly the small changes and how it actually works. Okay, let me just show you a simple example, guys. Okay, let's say you have a y value is equals to 2. Okay, and then you have a new y value which experience some changes, and then it becomes 2.001. okay, so the difference between the new y and the original y, that one we known as the small changes, because as you can see here, the difference between the y new and the y will be very little. So that little changes we're going to write down in terms of a mathematical form. Okay, so from here, since we are finding the changes in terms of y, so it will be delta y is equals to y new minus y. Okay, you can write y itself, or if you want to write y original also can, but I prefer you to write y original to be in safe side lah, guys. Okay, so y ori, so this is the original y value and this is the new y value, and the difference between two of them is the delta y, which means the small changes in y. Okay, so from here, delta y is equals to 2.001 minus with 2. So from here you get your delta y is equals to not 2, 0.001. okay, so delta y is represented as small changes in y. Okay, so if you have small changes in y, you must also have small changes in x. Okay, you can have small changes in x. Okay, let me show you another one more example. Okay, so from here, x original, okay, let's say you have 5. Okay, and then for some reason it undergoes some changes, and then it comes out a new x value. Okay, so now your new x value become 4.999. okay, so it undergoes some changes. So from here, the method is similar to finding the delta y, guys. Okay, the new you minus with the original. Okay, so from here, so to find your delta x, which indicates the small changes in x, is equals to x new minus with the x original. Excuse me. So from here, your x new is equals to 4.999. okay, and then you minus with 5. okay, the new value you minus with the original value. Okay, you minus them together. So from here you get your delta x is equals to negative 0.001. okay, in changes you can have a positive changes and negative changes, guys. Okay, doesn't mean you only must have a positive changes, you can have negative changes as well. Okay, that means if you have a positive change, that means your value increases, your new value actually increases. If you have a negative value, that means your new value actually decreases. Okay, that's the only difference. Okay, now, okay, this example we are going to go through later on. Okay, for now I'm just going to push it down. Okay, so we have learned some new terms, which is the delta y, delta x. Okay, so delta y indicates small changes in y, whereas delta x indicates small changes in x. Okay, now you might have a question. So how are you going to relate this delta y and delta x in terms of differentiation? So how are you going to relate it? Okay, there is a formula that you're going to apply. I'm going to show you the formula now. So from here, delta y over delta x is approximately similar to dy over dx. So this is the formula that you're going to apply for the concept of small changes and approximation. Okay, what does this mean? Okay, but before that, let me box this. Okay, this indicates that small changes in y, okay, when you divide with small changes in x, it is approximately same as differentiation of y with respect to differentiation of x. Okay, dy over dx. Okay, so they are almost the same, guys. Okay, that's why you have this approximation symbol. Okay, so let's say, for example, if you want to find small changes in y, okay, using this formula, so how are you going to find? So from here, delta y will be approximately equals to dy over dx, okay, and then you times with delta x. Okay, delta x means small changes in x, guys. Okay, so let me box this as well. Okay, and once you find the delta y, let's say if the question requires you to find the new y value, so what you need to do? So to find the new y value, so from here, y new will be equals to y original, okay, plus with delta y. Okay, so y new is equals to y original, and then you plus with delta y. Okay, delta y here we have already expressed, which is approximately equals to dy over dx times with delta x. So this formula we are going to substitute over here. Okay, so from here, y new is equals to y original plus with, okay, let me put in the bracket here, so dy over dx times with delta x. Okay, so this is the formula, guys. Okay, so I've already shown you some overall idea on how a small changes and approximation may looks like. Okay, so this is the quick theory of what is a small changes and approximations. Okay, let me show you one example, guys. Okay, so from here, okay, let us jump to our example now. Given that y equals to 3x squared minus 2x plus 5, calculate the small increase in y when x increases from 2 to 2.02. Okay, and then the question also asks us to find the new y value. Okay, so this is the requirement of the question. So let us start to solve this. Okay, so let me use a different ink. So from here, so the question already gives us y is equals to 3x squared minus 2x plus with 5. Okay, so from here, the first step what you need to do is you need to differentiate y with respect to x. Of course, you need to apply this relationship, guys, where delta y over delta x is approximately same as dy over dx. So the first step what you need to do is you need to differentiate this with respect to x. So from here, dy over dx will be equals to, okay, 2 times with 3, okay, you get it 6. So that you write the x, so the power you minus with 1, so you just leave it as 6x. Okay, this negative 2x you differentiate, you get this minus 2. Okay, whereas constant you differentiate, you get 0 lah. So the 0 you just lift it like that. Okay, so you already differentiate dy over dx, and that's how you get the 6x minus 2. Okay, that is our first step. Okay, the next is you just write whatever information in the question into the working here. So from here, the question gave us x original which in this case is 2. Okay, and they already give us the new x value, which is 2.02. So in this case, for some changes, the new x value have encounter a increment. Okay, so how much is the increment? So you need to calculate the delta x. Small changes in x, which in this case delta x is equal to x new minus with x original. So the new value of x you minus with the original value of x. Okay, so from here delta x is equal to 2.02 minus with 2. Okay, so from here you get your delta x is equals to 0.02. Okay, by the way, I'm doing this for the learning purpose, guys, so the step-by-step working, so that you can able to understand better. But of course, once you have done more practice, some of the redundant steps you can just omit, and then you can just jump to the answer. Okay, so you already find delta x and you have already find the dy over dx. Can we find delta y, small changes in y? Yes, we can, by applying this formula. Delta y over delta x approximately similar as dy over dx. Okay, so from here to find your delta y, okay, it's approximately similar as dy over dx, you times with delta x. Okay, so from here small changes in y, which is delta y, is approximately same as, so the dy over dx in this case is 6x minus 2, so the 6x minus 2 you just substitute over here. Okay, 6x minus 2. Okay, and then you times with delta x. Okay, the delta x in this case is 0.02. Okay, you times them together. Okay, but then you still can't get the delta y. Okay, because why? If you times this, you get your answer in terms of x variable, but then we need in a numerical form. So this x you need to substitute in some value. So what value you need to substitute inside here? You need to substitute the original value. Okay, remember this, guys. Okay, make sure you substitute the x original over here. Do not substitute the new value. Okay, I'm reminding this again. Always substitute the original value into this equation. Okay, guys, so from here delta y, okay, will be equals to, so we substitute the original x value, so from here 6 times with 2, okay, minus with 2 close bracket times with 0.02. Okay, you perform the calculation. Okay, so from here 6 times with 2 you get is 12, 12 minus 2 is 10, so 10 times with 0.02, so from here you get your delta y is equals to 0.2. Small changes in y is 0.2. Okay, alright, so from here the question asks us to find the new y value. So from here, in order to find the new y value, okay, let us write the formula. Y new is equals to y original plus with delta y. Do we find the original y value? We haven't find that. So the next step is finding the original y value. Okay, so how to find the original y value? The x original you substitute into here, you get the y original. Okay, I repeat again, this x original you substitute into this equation, and that's how you get the y original. Okay, so from here find y ori first. So from here y is equals to 3 in a bracket. Okay, so from here you have 2 square minus 2 times with 2 plus with 5. Okay, you substitute the original x into the y equation. So from here you get your y is equals to, so 2 square is 4, 4 times 3 is 12, 12 minus with 4 you get is 8, 8 plus with 5 you get is 13. Okay, so this is your y original. Okay, so thus, so y new is equals to 13 plus with delta y. So delta y in this case is 0.2. So from here your new y value will be equals to 13.2. So this is your answer, guys. Okay, let me underline the solution. Okay, there are a total of 2 solutions here, guys. First, the solution for the small changes in y, and then the new y value. Okay, so that is all. We have come to the end of the lecture video. So I hope you have understand the small changes and approximation concept together with the example that I've explained to you. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AddMaths lecture videos in the future, and make sure that you share this video with your friends. Thank you everyone for your support, and I'll see you in the next video.